example 2 has more of the same things as example 1, just upping the level of the algebra a little bit. So again, I'm going to start with A and rewrite what we have. So with the 8 and 6, again, the smallest common denominator between 8 and 6 is 24. If you have trouble seeing that, and you do 48, so if you, like, very common, and it's not a mistake, but it makes it a little bit harder later on, very common to multiply this one by 6 and this one by 8, because that would make them the same. This one has an 8, this one has a 6. We can make them the same with 8 and 6. That's perfectly fine, but then you'll have to simplify at the end, which can be more complicated. So if you can see that 24 is the smallest one, that's great. If you can't see it, maybe, right, maybe what we looked at before, and I'll do it here at the top. Instead of 8 and instead of 6, I could think of 8 as 2 times 2 times 2. And I could think of 6 as 2 times 3. Can you see that this one, in order for them to be the same, this one is missing 2 2's and this one is missing a 3? That tells me I need to multiply the second one by 4, the first one by 3. So this is just a method to, if you're having trouble with your times table in seeing it directly, this is a way to realize why and how you can get those numbers. It's a good strategy for doing it that way. Okay? Right? Sometimes, like for me, who's done times tables forever and is, I'd say I'm pretty good at my times table, right? I can just immediately see, oh, it's going to be 24 and do 4 and 3, but I have to take a moment and step back because sometimes we're coming into a math class and they're like, yeah, my times table. It's there. There's some numbers that need to be worked on sometimes, and that's okay. Always be working on your times table for sure, because you're going to use those skills for the rest of your life, right? Yeah, you have your phone, but at some point, your friend says, hey, what's 2 times 3? If you pull out your phone, let me just pull out my calculator and be like, really? Right? We do like to have some of them available. But it's nice that we have phones that we can check. 2 times 3 is 6. Here. All right, so erase this. There's the numbers, 3 and 4. Now we look at the variables. The variables, this one has an x squared, this one has an x. To make them the same, this one is going to need an x to make it x squared. The second one doesn't need anything more. What we've done now is we've made, and I like to draw the denominators first, I've made both of these denominators 24x squared. Still going to be a plus sign in between. Now in the top, and this is where this has brought it to the next level, this is 3x times the x plus 5. And this is 4 times the x minus 7. The 3x is not just multiplied by the x, it's multiplied by the whole thing on the top. And if it's multiplied by the whole thing on the top, you're going to have to distribute, which is going to give you 3x squared plus 15x. And same thing in the second one, that 4 is going to have to distribute, which is going to give you 4x minus 28. This is why this is sort of the next level. We have a little bit extra algebra to do in the top. It's all the same, like we're not introducing new algebra. These are algebra rules that you've learned since grade 9, but we practice them and make sure that we're not making mistakes along the way. Then, what is the rule for adding fractions? Once once we have that common denominator, well, the bottom's going to stay 24x squared, and now we have to add the tops. And in the tops, can you see that in adding them, we have two of them that are like terms? So that will mean that I have 3x squared. The 15x plus the 4x will now become plus 19x, and then minus 28. Okay? Here you're going to be tempted. You see x squared on the top, x squared on the bottom. Cannot cancel those out. Technically, all of this right now is one big factor connected with adding and subtracting. And the only way you can cancel something out is if you're multiplying and the factors are identical. So as soon as you're adding or subtracting, some students like to add those brackets to remind themselves those are all grouped together as one factor. And in that factor, could you factor it? Because to simplify, we would need to factor. Well, I look at 3, 19, and 28. There is not a common factor that I could pull out. And if there's not a common factor that I could pull out, the best I could do is factor this regularly. This one doesn't look nice at all. It doesn't factor nicely regularly. This would be your final answer, the best that you could do. I'm actually going to erase this to do part B. Is everybody good? All right. Again, I'm going to rewrite part B out. Common denominator between the 3 and the 5 is 15. So this one would need to get multiplied by 5 and 5. This one by 3 and 3. Looking at our variables, they both have a d already. That's good. This one has a c squared. This one doesn't. So the first one would also need to be multiplied by c. Again, this adding groups this together. This subtracting groups that together. And you're going to need to distribute when you multiply. Because that 3 gets multiplied to both things. The 5c gets multiplied to both things. So we have succeeded in getting I like color coding. We have succeeded in getting our common denominator. We have to distribute in the top, so I will get 15c squared minus 10c. And here I'm going to get 3c plus 24. Here is another place in algebra that you make mistakes that you would never make mistakes in numbers. Okay? So for example, I'll show you why you would never make this mistake in numbers. If I have two numbers like 5 sevenths minus 3 sevenths, what's the answer? 2 sevenths. This wasn't a trick question, I think. Perfect. Right? You would have no problem with that. Would you agree that it would still be 2 sevenths if I decided to change? Wow, that's not what I wanted to do. There we go. If I decided to change the 3 to 2 plus 1, did that change anything? Is it still minus? You would still get 2 sevenths, right? Okay. Here's what people do in algebra as a mistake. Okay? They do this. 5 minus 2 is 3, and and then plus 1 is 4. And they get 4 sevens as an answer. Can you see the mistake that they made? You know with numbers that the order of operations say, I should do 2 plus 1 first. But 2 plus 1 is 3, and then 5 minus 3 is 2. Okay? But what we have in the blue is two things that you can't add together. We have 3c plus 24. But we're subtracting it. We are subtracting all of this. Just like here, you subtract 3. You don't just subtract 2 and add 1. Technically, it's obvious that you had to do this first. But in algebra, sometimes you can't do that part, because they're not like terms. But we are still subtracting all of this. And again, because that's a factor group together, this is a factor group together. These are still like terms, but when I subtract, okay, you'd have 15c squared. Students make no mistake, they write 15c squared. You have minus 10 minus 3c, and students are like, awesome. They get minus 13. But then this is where students will make mistakes. And even though I tell you now, some of you are going to make this mistake over and over again. Can you see yourself be tempted and be like, oh, there's nothing as like terms with 24. I'm just going to write plus 24. Absolutely wrong. Why? Because you are subtracting all of this. And if you are subtracting all of that, you are subtracting the 3, and you are subtracting the 24. So it will be minus 24. And despite your best efforts to tell yourself, okay, I'm going to make mistakes on this. Pay attention. You will make mistakes with this. Right? I don't know, should I be extra harsh and take off 15 marks if you make that mistake? And then give you 14.5 marks if you make corrections? No, it shouldn't be extra harsh. But you will. Oh, this is the hard part for me as a teacher, is because I haven't found a way yet that works. Everybody's going to make this mistake somewhere. It's going to happen over and over and over again. It's like you know it's going to happen, it's going to be bad, and there's nothing I can do to stop it. But I think over time, the way that I teach it stops it more, right? So it's like you get a cut, right? You bleed, right? You need to stop the bleeding, right? I think that my students are able to, they still bleed, but we're able to stop the bleeding before anybody dies. So that's my analogy. It's not a great. Okay, so this subtracting is going to catch you. One's to practice. And again, I'll give you maybe 8 minutes this time, because these ones are a little bit harder.